you all same.
Thank you. Thank you, folks. Good morning. Thank you for being here so early on a Sunday. Yesterday, maybe it was hard for you. It was not that hard for me, but just a bit. So here, we're here to talk about OpenTelemetry Instrumentation. I was supposed to be giving this talk with my friend Israel, but he cannot come today. Maybe it's because he went viral a couple of days ago when he got a job offer from a recruiter asking him for 3 years of experience in DeepSeek, which is pretty weird. So now he's famous and he cannot come. Yeah, and you are stuck with me. And I'm Jose. I work now as product lead at VictoriaMetrics. In case you didn't know, there is a cloud product. I also work at the university teaching physics to some vet students in Madrid, in Spain. And yeah, I have a past like everybody does. And I also love playing heavy metal and sim racing. So if you do these things and you want to talk about them later, that would be super cool as well. So we are here to talk about instrumentation and OpenTelemetry. So you will be hearing this a lot, so I will try to make it super quick. OpenTelemetry is this project that's super huge and gives you APIs, SDKs, and tools to understand or to create observability, and this means metrics, logs, and traces. So things start to get a bit complicated and overwhelming because this means that these APIs, SDKs, and tools need to produce or ingest and show metrics, logs, and traces. And if you think about it, then you need to implement this in a lot of languages. So it's like, okay, now it's like, this is super overwhelming. The good part is that OpenTelemetry said, hey, or this super clever guy said, okay, let's establish a protocol so we don't care about what happens in these tools and we have interoperability. So the protocol helps to abstract that. And okay, I don't care which language you are programming your tool or mine, they just talk each other. And also it unifies in the protocol metric, logs, and traces, so you don't need a separate protocol for each of them, which is pretty convenient. And it also provides instrumentation libraries and auto-instrumentation for the code, so you don't need to think about it or put a lot of different libraries when you go to the code. So what is this thing about instrumentation? Let's start with zero code because it's fancy. So it's something that tells you effortless, helps you to create metrics, logs, and traces in your code, which looks super cool and it's great for your managers and because then you don't need to spend money doing this, but it has some inconveniences as well, as we will see. It's agent-driven. This means that, just imagine you are in Kubernetes, you will have an operator that will inject or activate some observability signals and in your code. And how is it done? It's done in 3 different mechanisms mostly, which is monkey patching or bytecode manipulations if we are talking about Java, or eBPF, right? Like I'm calling the kernel, there is an event in the kernel, and then I say, haha, you want to send a message, then I produce this metric or this span. But there are 2 super interesting calls later, talks later today about these topics, so I will let them talk more about that. I will be focused more on manual instrumentation. However, if you are curious about how this monkey patching works, for example, you can look at Wikipedia, super simple. Just imagine you are using this, this is an example before AI. Just imagine you are using a Python library and you want to say, hey, what's the number pi, right? Like 3.14. But then what you can do is, okay, at runtime, I change the behavior of this library. So at runtime, I change the value, and now it's like 3.2. The same as it happens with ChatGPT, by the way. But then it doesn't change the library itself. So OpenTelemetry, or these mechanisms, help you to, you have your library that is behaving in one way, but also you can, at runtime, change the behavior, so it starts sending metrics, logs, and traces. So that's the principle. And You do it by configuring libraries and exporters. For example, I want to generate metrics and send them to this endpoint. I want to generate, so this is what you will be doing when you do zero-code instrumentation. So there's nothing super fancy for the user, so it's pretty convenient. And it's great for edges and libraries. What I mean by this is you have your code, you would be, for example, calling your database, and you want to understand what's going on there. So the guys, super clever, of that database, they created some instrumentation for you, so you can activate or deactivate, so you can understand if you have issues in your code or in the database communication itself. So this is super good, but at the end of the day, not every language supports that. I come from the C++ world, and this doesn't work there. And it's also really hard to control the data, because you can be generating a lot of signaling, and if you don't treat it properly, then you can have a lot of increasing costs. And at the end of the day, we want to understand what's going on in our code. We want to understand if it's failing because of us, and you need to do something. So let's talk about manual instrumentation. That's why we are here. So when you start to include your OpenTelemetry libraries inside your code base, it's kind of hard. So actually, there was this survey a couple of months ago, or a month ago, that people were asking the community, hey, we need more examples. We need the documentation to be more thorough. So actually, this is a bit why this talk is, because when I was using to instrument my code, I was using OpenTelemetry, I had some doubts. So the first thing you need to understand, so now this is what we are going to talk about, how is this structured, how you can do it. The cool thing, as every other library, it provides an API and an SDK. So the cool part is that it's decoupled, so you can abstract yourself from, hey, where I'm sending my data. I don't care in my code, right? When I am processing my request, I don't really care where I'm sending my metrics, where I just want to don't pollute my code. So this is one of the principles. I have my API in which I say, hey, this is my +1 to this metric, but I don't care about the rest. And then you have the SDK. So let's start discussing how you do this for metrics, and we will also do it for traces and logs. For metrics, as I was saying, you normally have your function in which you want to add an error. So at the end of the day, what you want to do is say, okay, I have one more error, and then I don't care, I just throw it, and someone else will pick it up. So you do this by calling your API, and when you start reading the documentation, it can be, as every documentation, it can be boring, and that's why I'm trying to put here some fancy pictures. Maybe it's more clear. So you have these concepts that are measurements, instruments, meter provider, and yeah, okay, but I would just want to do like ++ my metric, right? My measurement. And then you also have the SDK, which provides you a reader and an exporter, and what is that? So this is what I'm trying to explain now. So they tell me, okay, we have a meter provider. When I want to create a measurement, I need to call a meter provider, and a meter provider is this thing that will give me a meter. And what is a meter? So it's my interface, the meter provider. The meter is something that tells me which resource is generating the metrics. So it's bound, for example, to a library, right? In this case, if I'm using a MongoDB library, it will be a meter with this name, right? And then I can ask for this meter for an instrument. And what is an instrument? In metrics, you can have different set of kinds of metrics of instruments, so a counter or a histogram, so that's a meter. So then I'm done, because now I have my counter, right, my instrument, and I can tell, okay, I have one more error, and I push it, right? So we are now done with our goal. We know how to say, okay, give me one more error, or I want to report that I had an error. Well, we just need one more thing, which is, if we go just to real code, what you will be having is you create, well, this is C++, of course, so lines can get long, but you create a set of labels, hopefully with no high cardinality, and you will say, okay, this ID or this response code, and then I add it to my labels, to my metric. And I also, the number, I just said, okay, I just have one more, but you can put 10, right? So this is it, right? So now these concepts come in again. I have a measurement, which is what I want to add, and I add it to an instrument, which is my counter. And then the other things are for the API. So that's cool, but what happens after that? Because I was wondering, like, okay, I just throw this metric, and now what, right? Well, it gets stored, into an aggregation store or into a local storage, and then the cool thing, and this is what I love about this project, is that it says, okay, now you define a reader and an exporter. So from this reader, you are able to say, okay, every second, every 5 seconds, every half a second, you say, now you get this data, you aggregate it, and you send it out. Where? In this case, okay, to an OpenTelemetry collector, but wait for it, because you can put another reader and say, you know what, leave these metrics here, because a Prometheus guy will come and take them. So now, I don't really care if in my code, if I decided that I would use a Prometheus, or if I would use OpenTelemetry forever, or whatever, because now I'm done. And how you define this? You define this, for example, in a separate file, or part in your code. You will be doing a singleton, or whatever, and this is how you do it. So super quick, here I'm showing you how would you define a reader. Like this, every second you get the metrics and you take them out. You will have define some parameters that you can do via configuration files. For example, hey, I have my OpenTelemetry collector or my backend there, so you define the exporter. So this is like configuration file, and yeah, a lot of code, and to make things work. So it's singletons and stuff. But that's it, right? So, and of course, this one was an example for the OpenTelemetry exporter, but you will have the similar function for Prometheus, if you want both in my example. So this is it, right? I have a measurement, I will throw it to my instrument, and that's part of the API, and then they will be stored and sent wherever I want. Period. I'm done. So now we know how to instrument our code with OpenTelemetry in C++. Well, no. It's not only C++, because the cool thing about OpenTelemetry is that it gives you this. It's a specification for every language. So every language that implements OpenTelemetry libraries need to do this. Of course, you will have nuances, but that's it. So now you know how to instrument in every language in the world. This is pretty cool. Now, traces. We are done with metrics. Let's go with traces. Normally, what I see is that everybody thinks they know traces, but then they have some misconceptions. So if you allow me, I will do a super quick introduction to traces. Because normally, what I see is people thinking, no, this is just a low-level log debug, and then I'm done. Well, no, it's a different thing, at least in this notation. So what is a trace? Bear with me for a second. It's just some spans I put together under a trace ID. Nothing else, nothing fancy. Spans under the same trace ID. And what is a span? It's a representation of an operation. And it has, because every operation happens in time, I have this time dimension, which is pretty cool, because it will help me in the end. So, and why are these important? Because when I have a distributed system, and a guy is doing some stuff in JavaScript that goes to a Go API, and then goes to my database, and then something fails, then I cannot save my day by doing kubectl logs, because then you are like, okay, what do I do with all of this, right? So if you have a span, you can track. If you have trace, you can track. You can trace your call, and with these spans, like, okay, this service called this function, that's a span, and then I have this other function, that's another span, and then I have all the context. So this is distributed tracing, okay? And at the end of the day, as I was saying, yeah, you can check it in a Gantt chart, which is the normal visualization. Now, let's get to instrumenting part. Now we are more experts, so maybe we don't need to go deep dive into all of them, but this is even simpler. So I started, spoiler alert, I started with the most difficult one. Now tracing is even simpler because there are no different instruments. I was saying, okay, you have metric counters or histograms, they are different. No, here we have a span. There's no different sets of span. You have a span and that's it. So our API gives us a trace provider, a tracer, and the span. So I will be reporting spans, and they will go to the SDK to export data. So it's the same kind of representation. And let's start from the end this time. It's just, okay, I will be defining my resource. This is an important concept in OpenTelemetry because I tell, hey, this instrumentation or this signaling is coming from this resource, in this case my library or my program, so I have that. So at the end when I want to check the data, I can understand where this is coming from. So I put my resource. I also say where I want to export my data, like, okay, I have an OpenTelemetry collector running there, and some options like batching, for example. I have processors, I can process my data, so I can check, okay, I can say, let's send it every megabyte. I don't want to have a lot of signaling, right? Another thing so that's for the SDK. Another thing I want to recommend, mostly in C++, because how it works, is to create this kind of auxiliary function that will help you to create child spans. Because what we want to do is to propagate context. Don't forget that. So I want to have a function in which I say, okay, create me a span out of this one. So it's just propagating the context. Nothing fancy, but it will help you, because when you are in the real world and you say, okay, I'm going to send an HTTP request. Okay, this is our example. Let's go with that. I want to send an HTTP request. So, hey, let's start my span, and I will set some attributes. Which attributes? How do you decide how to call these attributes? How are they going to function in the end? Well, that's a great question, because the OpenTelemetry project defines what they are called semantic conventions. And there is a semantic convention for a lot of things. As you can see, I don't know, like for CI/CD or function as a service, or for example, HTTP, which is our case. So by using the OpenTelemetry library, you will have all these things already in your code. Because you know, okay, I am sending a request that is going to this URL. How do I put this in a span so I can check it in the end, so it's so easy? Okay, you just use this, you just add it to the span, you just use the primitives from the library, and you're done. You don't need to overthink or redo, so it's pretty cool. After that, so I added my URL to my span, I send my request, and what I do now is say, okay, my counter, remember we had our counter, okay, +1, I sent a request, so that's another counter, it's not an error, and I add an event, which is another very important concept for traces and spans. It's not only about having this one called this one. No, you can add your logs. We all love to say, hey, I was here. Hey, this failed. Hey, I don't like this. If I am here, we are all screwed, right? These kind of things, we want to add them. So these are events in this jargon. And yeah, so, okay, I send this is just continuing with the example. I send my request. When I get my response, I will be adding another event. Hey, I will show you now in a super short demo. But then I can also validate my answer. And if it went bad, I can also add another event or set my span as this span was an error. So I can check in the end the trace. And we are done. However, we just need one more thing. If you are wondering how the hell this propagates, well, because you need to propagate the context. The service at the other side needs to understand your span and your library and things. So how does this travel? It travels, for example, in HTTP, it travels via headers. So, but then you need to invent them. No, this is standardized. And actually, these are the headers, and you will use them, just to give you a hint. So the library will handle this for you. In C++, if you want to do it yourself, you know, like, it's super big and everything, but it's just a couple of functions that you will say. The concept is super simple. Is, hey, I have this request coming from HTTP. Please inject them in this span. Or I am sending a request. Okay, let's take from my context, from my, the library, the primitive, and put them into HTTP headers, and I'm done. So that's the only part we were left. Yeah, we can do this super quick. Just to show how, why is this important and how does it look like? I have here I have here a client that is sending 100 requests per second to a dummy server. And so let's give it some time so it generates data. And here we go. And let's refresh. And at the end of the day, what I'm going to look is to some spans, you know, like a trace, and I can check on them. And why all of this that I was saying is important? Well, we have now, I know it's super small, but we have these spans, because what I'm doing in my client is I send a GET request, then I get the response. I send a PUT request, then I get the response, so I can check the behavior of this other service at the other side. So the cool thing is, because I was instrumenting my spans with these OpenTelemetry standards and libraries, now I can inspect my span, and I can check here that, okay, this span corresponds to a POST method, and it received a 200 code, so everything is okay. Jose, you don't need to worry about these things. It was in OTLP format, it was a client. You remember I was saying this resource, okay, I said client, now I have here a client. I know this span is coming from a client, and also the URL I was calling was this one, and I can also have some information about the library that is generating this, so I can see that. And the other cool part is I have here my logs, right? So I was talking about metrics, logs, and traces. Traces, when you start using them and understanding its power, maybe you start to put less logs to the pipeline. And in case you were wondering, for metrics, yeah, now we have them. This is, by the way, I was just sending these metrics and traces to an OpenTelemetry collector, and of course, storing them in Jagger and here in a VictoriaMetrics instance. And here, you know, this is OpenTelemetry. In case you are not used to OpenTelemetry and more to Prometheus, you can visualize it the same. So you don't need to, for the user, at least this is not an issue, right? So you can easily take that. So that's it for the demo. Let me go super quick to logs, and we are done. Yeah, and in case the demo didn't work, I had those screenshots. Logs. You all know logs. That's the first thing we do as programmers. Hello world, that's a log, that's observability, right? We are all experts in observability and logging. So what I am proposing you here, right, is use, well, me, everyone, is metrics, logs, and traces with OpenTelemetry library, and that's it. Why? After all, you will tell me, yeah, but I like to just print to the console, yeah, whatever. We all do it. Actually, if you go to the OpenTelemetry library, they have, in their examples, they are printing to the console as well. So why shouldn't I? Well, if you continue doing this, first of all, you have already the library. You are using it for metrics and traces. So why not for logs? You can add attributes, for example, in an OpenTelemetry collector, if you use it to collect the logs. You can add the attributes, which are standardized, like, hey, this is coming from this container or this namespace. And you can also filter and batch, so you don't have a lot of signaling. You can transform and process the data, so it's pretty convenient. You can also help for correlation. For example, logs, if you add a trace ID, can you imagine how cool is that? Because now, because you like to look logs, okay, and you do your kubectl logs, if you see a span ID, now I can go to Jagger and check, okay, this is all the context. Cool, right? So there are many reasons why you should be doing this. Also, yeah, we all love, or for example, in C++, when you are instrumenting logs, then you start to reinvent the wheel, because you start, how do I activate or deactivate the login? How do I reduce the login level? How do I, and then you start, we all have that coworker, or even inside ourselves, that likes to reinvent the wheel and create another library for this and all that, and things can get messy. We already have it. Why don't we use it? However, I know you guys will be still using it. I will still be doing that, and I will just, hey, I have an error. I just put it to the console, and I'm done. Okay. If that's your case, it's okay, because what means putting your errors to the console? It means that when Linux is a file, you are putting your logs into a file. So the OpenTelemetry collector can read them, process them, and do all these things, and send them. Of course, you will lose some things, like correlation. You cannot correlate an ID if you didn't instrument it with a span, but at least you get something out of it. So it's not that bad. And, okay, you are experts now in this. You will be creating your resource and adding it to an exporter and the processors and all of that. So you already know how this works. It's the same for all ones. And this is how it looks. So it's not that bad. I mean, it's super quick. You just say, okay, give me my logger, and I log my data. However, what I would recommend is if you are using traces, let's add your span IDs, because now you can, at the end, correlate. So it's just a small thing. But, and this is the last part, why, how does it look like, right? We know, hey, error here, that's a log. This is a log in OpenTelemetry, okay? It has those resources, it has maybe some timestamps, which is good because at the end you like the timestamps, you want to add them, right? It also has all this information about my library that I was showing, so this is all standardized. So my only message here is like, watch out, because these things can be expensive. We love to put a lot of logs there, but we will have, as I was saying at the beginning, there is another talk on how good or bad is auto-instrumentation. The same goes for manual instrumentation, right? Normally, at least in my experience, one of the biggest issues we had in performance was because we were logging a lot, and we needed to reduce them. And also with costs, right? Okay, so as a summary, if I want to give you some takeaways, or I would like you to take some things home, try to mix both worlds, because automatic instrumentation is also nice, but now hopefully you know a bit how to do a manual one. OpenTelemetry will help you decoupling the SDK from the API, so you can abstract your business logic from where you are exporting data and changing the exporters in this case. And semantic conventions, don't forget them, they are super important because they help us to correlate all the data and understand what the hell is going on. And okay, if you still want to, print, then if you use a collector like the OpenTelemetry collector, it will help you to inject some data and enrich your data so you can have good observability in the end. So that's it, and now we are open for questions. Thank you.
Do we have any questions?
Was rough last night, right?
I had a question about using it in embedded settings. So I have an embedded Linux system that I want to apply OpenTelemetry to.
Sorry, I cannot hear. Let me.
Is the mic not working, or?
Maybe it's.
I have an embedded Linux system I want to apply OpenTelemetry to, but I'm worried about things like the aggregator. How long does it retain it across reboots and stuff?
Mm-hmm.
Have you tried using it outside of like a Kubernetes cluster before?
So you mean inside the code? Like in the...
I'm just talking like instead of on a cloud somewhere, like doing it on an embedded device with a battery and limited resources. Mm-hmm. Do you know how OpenTelemetry will fare, or? Yeah,
in terms of, so if I understand correctly, you want to use the OpenTelemetry API and you are seeing that it's aggregating data and maybe it has some performance. Just imagine, or what, in my experience, what I saw is that it's actually convenient to have that, because otherwise you will be sending, like all the signals one-to-one, and then you have like a lot of networking issues because you are having all that bandwidth. Of course, you will need to fine-tune in the end how these things are, but I haven't experienced any issue with these parameters. It's just more like, okay, really, I just send 1 second of aggregation and I'm done. Of course, if your process goes down, then you may lose some data, but maybe, yeah, when things explode, it's not easy to debug. That's true. That's a great question. Thanks.
In the upcoming profiling signal, will there be also automatic and manual instrumentation?
So if profiling signals will have automatic instrumentation, I'm not an expert in that field, so I will not lie to you. I believe yes, because I believe it's done with eBPF, but I will shut up and maybe there are other talks later, so maybe they will help you with that one. So.
Is that it? Let me say thank you.
Thank you, guys.
So do we have the next speaker present?